Wishing you a very good morning, everyone. Today we have the new team, another team, a team called Smart Six with us. So I'd like to hand over the mic to them to introduce their model all about. It's looking very interesting. You can see new things are being introduced here. Right? What is the topic about? De- yeah, demonstration of first and second law of motion. So I'd like to hand over the mic to them and to continue their model.
A very good morning, everyone. Respecting Honorable Sir Amit and you all my dear classmates. We are the team members of the crew Smart Chicks. My name is Jennifer.
My name is Munni. My name is Krishna.
We thank Sir Amit for giving us this beautiful opportunity and we hope you all like our model.
So today, say to stay, state. Do you know what is the first law of motion states? So to state the first law of motion, I would like to call Krishna.
So now I will state the first law of motion. Anything in rest will remain at rest, and anything in motion will continue in motion unless it is compelled by an external force. So now I would like to call Munni to explain the first law of motion.
So good morning, everyone. My name is Munni. So as to demonstrate the first law of motion, here we have a ball. So right now this ball is in a state of rest, and there is no net force acting against it. So in order to move this, we have to apply force. So now I'll apply force like I'm pushing it. After pushing it, this ball has changed its state. This has changed its state from rest to motion. It started moving. So this is what the first law of motion demonstrates. The first law of motion states two things. The first is that a stationary object will only move when you apply force on it. This is what happened now. The second thing is that a moving object will only change its speed or direction when a force is applied to it. Like I'm doing it now. The ball was in motion, and after hitting the grasses had put force on the ball, and the ball has changed its direction and speed. It didn't stop. Indeed, it's changed in direction and speed. So this is how the first law of motion can be demonstrated. Now let us see what the second law of motion states.
So let me state second law of motion. It states that the rate of change of momentum is directly proportional to the applied unbalanced force in the direction of force. So Jennifer will explain.
So now let me and Sneha explain the second law of motion, the model here. Here we have two balls. This is a stone, but consider this is a ball. Okay, so as you can see here, there is a small hole. As you can see there, it made a small hole. Now we are gonna put the other ball there and let's see what happens. It made a big hole here. So it is, we observed that the small ball made a small hole and the big ball made
Deep. It makes an impression.
Yeah.
Deep impression.
a deep impression. So the second law of motion states force equal to mass into acceleration, which means that the force acting on an object is equal to the mass of an object. This means the more mass an object has, the more you need to accelerate it. So let me- Where's the second guy?
So this is our demonstration for first and second law of motion given by Sir Isaac Newton. So yes, sir. Yes.
Okay, very nice. So let's clap for them. So very nicely they have demonstrated the first one, second law practically, which we have read in books. Today they come out with a model and they have presented so nicely, so beautifully. I'm really happy what you have explained it, the real application of first law and second law. My motto is to make you understand practically, and which you did. Congratulations once again. So before that, I'd like to ask some questions, as there are 5 members, so I like to raise some 5 questions here. So can you say me, Miss? You have said it enough. Okay. What is the rate of change means? Rate of change means
Rate of change means
What does this term actually means? Rate of change. So nice, beautiful. Statement.
I think it changes from its place to place. I think.
I have listened so many times. What is the rate of change? So you say simple thing. Change means what? Change means what?
Like moving forward to next place to next.
Suppose you got 17 plus 8, now you got 80. Change is there or not? So you're moving on. What does change mean? Change means simple word. Change means the difference in the value. What's sir? Change in the value. Suppose yesterday I have 10 rupees, now I have 30 rupees. So there is a change, right? The difference is called the change. Okay? Okay, fine. Next question. Munmi is here. Munmi, what is momentum?
The product of mass and velocity is defined as momentum.
Okay, very nice. So how can we increase the momentum? What are the various factors we can increase the momentum?
I don't know, sir.
Can you say the various factors, how can we increase the momentum?
No.
Okay, sir. Can you say? Munmi can say? Momentum means what? Mass and velocity. The product of mass and velocity. So if you increase mass also, then also momentum increases. If you increase velocity also, then also momentum increases. Like train has less speed, but it has more mass. So its momentum is very high. But a bullet has less mass, but more velocity. So its momentum also high. Okay. So now, okay. So can you say me what is inertia?
First law.
Inertia means, yeah, inertia is a part of first law, but what is inertia?
Inertia means first law of motion.
The term, the meaning of this term, what is inertia? Everybody is inertia. The ball is in rest. It is in rest. Okay. So inertia means what? Inertia means what? Can you say inertia? Okay. Anyone can say the meaning of inertia here? Inertia meaning, you get point for this. Come here. Come here soon. Time. So clap for them, clap for her. Okay, good. So should I to get the answer of inertia?
Inertia is the tendency of an object to resist its change in the state of rest or motion.
Very nice, very good. So inertia is a tendency, is a property of any object which resists the change in it. Okay. So okay, fine. Any public question? Any public question? Huh? What is 1 Newton? Yeah, define 1 Newton. We have not prepared so well.
Yes, sir. Force acting on an object of mass 1 kg